Welcome to Educational Well channel. Welcome to A-Level Chemistry. This video focuses on interpreting mass spectrum. Mass spectrum shows the percentage abundance versus mass to charge ratio. There are peaks at different mass to charge ratio. Each peak in the mass spectrum represents an ion with mass to charge ratio and it is abundance. Mass spectrum is used to identify the different isotopes that make up the element and relative abundance of isotope that also used to calculate the relative atomic mass and molecular mass and used to identify unknown compound. This mass spectrum shown is of hydrocarbon that has been produced via electron impact ionization. Fragmentation is very common with electron impact ionization. The peak with the highest mass to charge ratio is due to molecular ion, that is 56. There's a small peak that is due to isotope of carbon-13 or hydrogen-2. That is M+1 peak. Peaks lower than molecular ion is due to fragments. So the mass spectrum shown is of protein that has been produced by electrospray ionization. Electrospray ionization used to determine molecular weight of larger molecule like protein, peptides. You can see two peaks here at mass to charge ratio 485.1, that is due to molecular ion. And a next smaller peak at mass to charge ratio at 486.1, that is due to N+1. Electrospray ionization, ion is produced by one proton is transferred onto a neutral sample molecule producing an ion. Therefore, 485.1 is mass of molecule and one proton. Mass of molecule itself is 185.1 minus 1 is 184.1. As I said earlier, mass spectrum can be used to determine relative atomic mass of an element. The mass spectrum of boron is shown here, that giving the relative abundances. So the boron isotope 10, relative abundance is 23, boron isotope 11, relative abundance is 100. Therefore, calculating relative atomic mass, so the abundance 23 times mass to charge ratio 10 plus relative abundance 100 times mass to charge ratio 11 divided by relative abundance, total abundance is 123. Mass spectrum is used to identify unknown element. The peaks below shows the mass spectrum of element X. So the percentage abundance versus isotopic mass. So finding the relative atomic mass by percentage abundance time isotope mass 82.8 times 24 plus percentage abundance 8.1 times isotope mass is 25, 8.1 times 25 plus percentage abundance 9.1 mass to charge ratio or the isotope mass 26 plus 9.1 times 26, percentage abundance is 100. So the relative atomic mass 24, that is the element is magnesium. Interpreting diatomic molecule. This is chlorine molecule. Chlorine diatomic molecule Cl2 1 plus. Relative abundance of chlorine 35 isotope is 75%. Relative abundance of chlorine 37 is 25%. Possible molecular combination. So some chlorine molecule consists of 2 atoms of chlorine 35 isotopes. Some chlorine molecule consists of 2 atoms of chlorine 37. Some molecules consist of both isotopes, chlorine 35, 37 or 37, 35. Now calculate the abundance of each combination. Calculate the relative abundance of each combination. So the using probabilities. So the chlorine 35 isotopes, 2 atoms, chlorine 35 isotopes, giving the percentage abundance 56.25%. Chlorine 37 isotopes, both atoms chlorine 37 isotopes, probability or the percentage abundance is 6.25%. So the combination of atoms chlorine 35 and 37, percentage abundance is 37.50%. Now mass spectrum peaks at mass to charge ratio 70 and 74:72. Mass spectrum of chlorine gas sample. Chlorine molecules become ionized to form chlorine molecular ion. Ions are quite unstable. Some molecular ion open split up to give chlorine 1 plus ion. That this mass spectrum has 5 peaks. So a peak at mass to charge ratio 35 represent chlorine 35 plus ion. At mass to charge ratio 37 represent chlorine 37 isotope plus ion, and peak at 70 represent the chlorine molecular ion with the 2 atoms chlorine 35 isotopes, and 34 represent the 2 chlorine molecular ion with 2 chlorine atom chlorine 37 isotope, and 72 represent chlorine molecular ion with combination of isotopes chlorine 37 and chlorine 35. Question: bromine has 2 isotopes, bromine 79 and bromine 81, approximately equal abundance. In a TOF mass spectrometer, bromine forms ion with formula Br2 1+. Sketch the pattern of peaks you would expect to see in the mass spectrum of sample of bromine. So again, possible molecular ion combination. Both atoms, bromine 79 isotope, mass to charge ratio 158. So the percentage abundance 25%. Both atoms, bromine 81 isotope, mass to charge ratio, peak at mass to charge ratio 162, relative abundance 25%. Other one combination of isotopes, bromine 79 and bromine 81. So the mass peak at mass to charge ratio 160, relative abundance is 50%. Another question: sample of chlorine was placed in a mass spectrometer. In this sample, chlorine 75% of atom were chlorine 35 and 25% were chlorine 37. Mass spectrometer detect only chlorine 1 plus and chlorine 2 plus ion. Spectrum obtained containing 4 peaks. Diagram below is an incomplete spectrum showing only peaks produced by chlorine 35 1 plus ion. So this is the peak shown in the spectrum, that is due to chlorine 35 1 plus. So that has chlorine 37 1 plus. So that is 25%. Now M2 ion generally has lower abundance than M1 ion because it requires more energy to remove a second electron. Therefore, chlorine 2 plus molecular chlorine 2 plus isotope 35. So the mass to charge peak at mass to charge ratio 17.5. Chlorine 37 isotope 2 plus ion. So the mass to peak at mass to charge ratio 18.5. But both relative abundance of both the peaks are smaller than the chlorine 1 plus ions. Thank you for watching. If you enjoyed this video, don't forget to like, share, subscribe to the channel for more content. Hit the notification bell so you don't miss any update. Let me know what do you like to see next. See you in next video. Thank you.